everyone, and welcome to Elsie's Young Learning Emporium. In today's video, we're going to be looking at factorizing expressions, part 1, looking at linear expressions. So, let's get into this video. This is a very basic video, by the way. It starts from the basics, very basics, like you probably won't have a lot of questions during this video because I've really tried to go step by step from the basics, and then it gets into more complicated stuff, which is like uses of factorization and all of that. It's all in this video, so I hope you really enjoy it. Let's get into it. So let's look at what will be in this video. So first, we're going to look at what really are linear expressions. Then 2, we're going to look at how to factorize linear expressions. Then 3, we're going to look at some practice questions and uses of factorization of linear expressions. So let's start by looking at what are linear expressions. So a linear expression is basically an expression where the highest power of the variable is 1. For example, x plus 4 is a linear expression. So first of all, the power, which is the exponent on x, there is no over here, but basically even if it's not there, it is 1. Alright, it's not 0 because anything to the power of 0 is equal to 1, so it's 1 because we just have 1x. We don't have x squared, we don't have x cubed or anything like that. We just have x. And x plus 4 is an expression because it does not have an equal sign, so that is a linear expression. Then we've got 2x minus 5, which is a linear expression, and then we've got 2x divided by 5 plus 3x, which is a linear expression as well. As you can see over here, all of the x's over here have no exponent, which means that the exponent on x is actually 1. So now let's get into the second step of this video, which is how to factorize linear expressions. So let's get into it. So what is factorization, right? This is a simple question that we need to understand before we get into this video. So factorization is basically the opposite of expanding. You know when you've got like a bracket like 4x plus 2, and then you go ahead and you multiply and you get 4x plus 8. That's it. Okay, so this part, the 4x plus 2 in brackets, this bit, this one, that is the factorized version of this, because what we're doing is that we need to break down an expression, which is this is the expression, into its factors that would multiply together to give the original expression. So here we multiplied these to get this. All right, so now let's get into how to do it. Now that we know what factorization is, let's get into how to do it. So take this example. We need to factorize 4x minus 2. That's going to be simple because the step 1 is we find the prime factorization of each term and find the HCF, which is the highest common factor. Wow, that was a lot of words, right? So let's break this down a little bit. Basically, if you know what prime factorization is that we're going to write each of these numbers as a product of primes that multiply and make that number. So let's start off with 4x. So we are going to go, so this is basically equal to 4 times x, right? And we can break down 4 further because that's not a prime number. So we can break it down into 2 times x. So now we can write this all out as 2 square times x, because 2 square is basically 2 times 2. All right, so now we're going to move on to 2 and the prime factorization of 2. We know that 2 is a prime number, so it's just 2 to the power of 1 or just 2, right? So now highest common factor, to find highest common factor, we're going to find the common factor which is the smallest. If you know what I mean, basically this means that in each of the numbers we've got these factors, right? And now we're going to look at the largest factor, which goes into the smaller of the number, right? So we get that the common factor over here, so the common factor is going to be 2, and that's why the HCF is 2. Now we're going to move on to the second step, which is finding the HCF, which is putting the HCF outside the brackets. So earlier, when we took our example, we had the expression and then we had some brackets and a number. So that's what we're going to do over here. So we know that 4x minus 2, we need to get this down into brackets. We know that the highest common factor over here is 2. Now we're going to try and make the first term. What do we multiply 2 by to make 4x? That would be 2x, all right? And then for the second term, which is minus 2, remember the negative sign. If it's a positive, then it would be positive 2, otherwise it's negative 2. So to make negative 2, we need to multiply 2 by minus 1. So basically, this is equal to 2x minus 1, because if we expand this, we're going to get 2 times 2x, which is equal to 4x, and then we're going to get 2 times minus 1, which is equal to minus 2, and there you have it, the original expression, right? So that's basically how we can factorize an linear expression. So now let's move on to this third step, which is the practice questions and the uses of factorization. So we're going to start with factorizing 6x plus 12, So obviously the first step is to find the prime factorization of each of these terms. So 6x is equal to, 6 times x. We can break down 6 further into 2 times 3 times x. Now let's move on to 12. So 12 is equal to 2 times 6. 2 cannot be broken down, but 6 can be. So we get 2 times 3 times 2, which is equal to basically 2 squared times 3. Great. So now we're going to find the common factor between this and this. So we know, here's the common factor. We know that 3 is a common factor, and we know that 2 is a common factor because 2 square is equal to 2 times 2, right? And we see a 2 here and a 2 here. So the HCF is equal to 2 times 3, which is equal to 6. Okay. Now we're going to remember that the HCF is 6, and we're going to use that to factorize. So now we've got 6x minus plus 12. That is going to be equal to 6, and then in brackets we're going to have some numbers. So first we need to make the first term, which is 6x. What should we multiply by 6 to get 6x? So that's going to be x, because 6 times x is equal to 6x. Then we've got 12 as our second term, and now we're going to think about what number should we multiply by 6 to get 12, and that is going to be 2. So that's why the factorized version of this is going to be 6x plus 2. Okay, now let's look at the second example, which is factorize 10x minus 5. So first we're going to write out the prime factorization of each, which is 10x is equal to 10 times x. We cannot simplify that, but we can simplify that into 2 times 5 times x. Beautiful. That's the prime factorization. Now we're going to look at minus 5, or just 5 if you like. I think 5 just works a bit better, but we can do minus 5 here. And the prime factorization of minus 5 is basically equal to 5 times negative 1, right? So now we're going to look at the common factors over here, and obviously there's only one, which is 5. So the HCF over here is equal to 5. Now remember that the HCF is 5, and now we can write out 5, and then we have some numbers in the bracket. So we're trying to make 10x minus 5. To make 10x, we need to multiply 5 by 2x. To make minus 5, we need to multiply 5 by minus 1. And that is the factorized version of 10x minus 5. Now let's look at 5m plus 10 plus 15m, and we need to factorize this. Before we start, it's really important we look for whether we can simplify this before we start. So since we've got like terms, which is 15m and 5m, we can add them up because that's what it's asking us to do. So 5m plus 15m is equal to 20m. and we've got 10. So this becomes 20m plus 10 when we simplify this. Now, this is our actual expression that we're trying to get, okay? So we're going to find the highest factor over here. So let's write out the prime factorization of 20 and 10. So 20 is equal to 2 times 10, which is equal to 2 times 2 times 5. And then 10 is equal to 2 times 5. So we can see that 2 times 5 and 2 times 5 is common over here, so which is equal to 10. So that's why 10 is going to be our HCF over here. Okay, so let's remember that 10 is our HCF, 10 is our HCF, so 10 is our HCF, and then in brackets we have something. This expression turned into 20m plus 10. So now we're trying to make 20m. First, to make 20m, we need to multiply 10 by 2m. Now to make 10 from 10, we just need to multiply it by a positive 1. Remember, it's positive, so that's why it's just going to be this. So it's 10 times 2m plus 1, which is in brackets. So let's remember this, 2m plus 1, 2m plus 1. So we've got 10, 2m plus 1. This is our answer. Now let's move on to the uses of factorization. Let's imagine you have to rearrange this, and we don't know how to factorize. Then it's not really possible. It's going to be really hard. I don't think there is a way without factorization, but there might be. Don't take my word for it. But we need to know factorization to do this easily, right? So we need to make x the subject over here, all right? So we've got y is equal to ax plus bx. So what we can do over here is basically factorize this, okay? So let's do that first. So it's equal to y, and over here we're going to find common factors over here. It's quite simple because these are variables and you can't really break it down into prime numbers or anything. So that's why we're just going to look at the factors over here. We've got x, we've got x, and we've got x. So this turns into, we get the x out because it is the HCF of ax plus bx. Now, in brackets, to make ax, we need to multiply x by a. And to make bx, we need to multiply x by b. And that is how it looks like when it's factorized. Now, to make x the subject, we can shift this whole number, this whole factor, a plus b, over here. Since it is being multiplied over here, when it goes to the left hand side, it's gonna get divided. So that would mean y divided by a plus b is equal to x. And that is how you can use factorization to make rearranging a whole lot simple. So you don't have to worry about using anything other than factorization over here. Now we can also make solving easier. So for example, you've got this over here. You've got 12x minus 12 is equal to 0. Let's go ahead and factorize this. So 12x is equal to 12 times x. I'm not going to bother simplifying 12 because here's what happens. When you write 12, it's just 12 times 1, and we can simplify it more, but we're already seeing this large factor over here, so we don't need to break it down further. You can basically do this in your head as well. So we've got 12, and then in brackets we've got x because 12 times x makes 12x, and then we have got minus 1 because 12 times minus 1 makes minus 12, and that is equal to 0. Very simple from here, because x minus 1 is equal to 0 by divided by 12 because it goes down here, and then that means that x minus 1 is equal to 0. What this really does, it makes it very clear what is equal to 0, because 12 isn't equal to 0, so this must be equal to 0 for this whole thing to be equal to 0, right? So that's why x minus 1 is equal to 0, which means that x is equal to 1. So I feel like this was as easy as it gets with factorization, because with solving, I find that without factorization it's a bit easier for me, but it's really up to your preference. This can be a lot clearer as well sometimes, but I think both are options. You could also go ahead and do this. So 12x minus 12 is equal to this, and then you've got 12x is equal to 12, so x is equal to 12 by 12, which is equal to 1. So that's also a way. But these are the users, and these are some practice questions. So that's it for this video. I really hope you enjoyed. I really hope it all made sense to you and that you learned something new. If you have any questions, pop them down in the comment section below. And if you did like this video, please drop a like and share it with other people, and also please subscribe if you did like this video. So thank you so much for watching. I'll see you next time. Bye!